Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about planetary winds. In this lecture, we will be discussing on isobars and pressure gradient. What are all the contents we are going to discuss in this lecture? They are the patterns of isobars and pressure gradient, the causes of pressure gradients, and how to read the isobars and pressure gradients on map, and seasonal pressure pattern across the globe, and importance of isobar analysis. So, these were all the contents we are going to discuss in today's lecture. So, what is meant by isobar and pressure gradient? That is, atmospheric pressure varies across the region due to the temperature and altitude difference. So, because of the temperature and altitude difference, so this atmospheric pressure varies from one latitude to another latitudes. The isobars connects the points of equal pressure on weather map. That is, the isobar, for example, if it is going to be a high pressure region, that is 1020. So, these region have 1020 millibars. So, because of that, the 1020 millibar region is connected, and this one is known as the isobars. The pressure gradients control with wind speeds. If it is closely spaced isobars, it means the strong wind. If the isobars are closely spaced, it represents the strong wind. In vice versa, if the isobars are widely spaced, it is the gentle wind, that is, it is a weak wind. The wind flows always from the high pressure region towards the low pressure region, following the pressure patterns. The pressure analysis is essential for weather forecasting and climate studies. So, for climate studies and weather forecasting, this isobars and pressure gradients, so all these understanding is required in order to read the forecasting of weather and then the climate studies. What is meant by atmospheric pressure? The atmospheric pressure is the force that exerted by the weight of the air. If there is a weight, what happens? There will be a force which is exerted. That pressure is known as atmospheric pressure. It decreases with altitudes. So, if there is an increase in altitude, the pressure will be, atmospheric pressure will be decreased, which thins the air. Because of thin of air, the air will be very thin. It is influenced by temperature, humidity and air density. So, the factors which determines the atmospheric pressure is the temperature, humidity and air density. So, it is measured by millibars or it is measured by hectopascals. So, these were all the measurement which is used to measure the atmospheric pressure. It is important for the global weather pattern. So, in order to determine the global weather pattern, this atmospheric pressure is most important. What are all the causes of pressure variance? That is, heating and cooling process of air change is its density, that is heating process and cooling process which changes the density. Either by heating it loses the density, the air loses the density and rise up, or by cooling it gains the weight. So, that is the most important factor which is causing the atmospheric pressure variation. The warm air rises creating low pressure, the cold air sinks and forming the high pressure. This higher moisture reduces the air density, that is lowering the pressure. So, the topography and altitude affects the pressure distribution. So, the topography, either it may be a plain section or it may be a mountainous section. So, that altitudes which affects the pressure distribution. The Earth's rotation causes the seasonal shift in the global pressure belts. So, the Earth's rotation, that is Coriolis force, again here it is influencing in the seasonal shifts of the global pressure belts. So, in the atmospheric pressure belts we have discussed this point. Meaning of isobar. So, isobar is the line joining of equal atmospheric pressure. So, see here, that is 960 isobar lines are connected here and 970 isobar lines are connected here. So, in such a way that the entire line which is connecting the equal pressure air pressure area is known as isobars. That is, it is drawn on synoptic weather chart. So, we have a synoptic weather chart. So, in that chart you can come across this isobar lines in any place, any region, you can see the air pressure distribution. And you can also witness the standard intervals, how far the interval is here. So, you can see here there is a wide interval. So, here there is a less interval. So, that intervals can be analyzed in this synoptic weather chart. The patterns indicate the cyclones and anticyclone. So, cyclone means the pressure will be low and anticyclone means the pressure will be high. So, this pattern will be indicated in the isobars. It helps to interpret wind and surface weather condition. So, because of this isobar, what is the use of it? It helps to analyze or interpret the wind and surface weather conditions. So, what are all the properties of isobar? That is, the low pressure system have a minimum pressure at the center. So, if it is going to be a low pressure, the pressure here will be a minimum pressure and the air will be converge and rises. Why the air is converging and rising? Because of the heating process. So, because of this convection process, it causes the clouds, rainfall and unstable weather in this low pressure region. And the wind moves inward and rotate clockwise. So, in the cyclone, how the wind will be moving in the northern hemisphere? That is, it rotates in the anti-clockwise movement. So, in the northern hemisphere, the wind rotates in the anti-clockwise movement. It is vice versa in the southern hemisphere, it is a clockwise movement. Thus, it has the steep pressure gradient which produce strong wind and stormy condition. So, in the cyclone, how the wind will be? The wind will be very strong and it have a stormy condition. So, this will be prevailing in low air pressure region. They are associated with cyclones, depressions, storms, monsoon rainfall. So, these are all the weather patterns which have been executed because of this low air pressure. There is a circular isobar. It indicates cyclone and anticyclone. So, always the cyclone and anticyclone will be in the circular motion. And then if it is going to be a elongated pattern, it shows the ridges and troughs. This ridges and stuff we will be discussing in the upcoming slide in detail. The asymmetrical bar, isobar, which represent the uneven heating and relief. That is, if it is going to be a symmetrical, there will be a uniform wavy pattern. If it is going to be asymmetrical, there will be a ups and downs. This ups and downs is because of the influence of the different altitudes, that is relief feature, as well as the differential uneven heating process. This wavy pattern, that is, if the isobar is wavy in pattern, it is linked with the mid latitude disturbance, that is wavy, that is the jet streams in the mid latitude region. So, it is a wavy pattern. The isobar pattern shifts seasonally. So, there is a seasonal shift of isobars. It is because of what? It is because of heating, that is ITZ zone have these shifts due to the apparent movement of sun. So, that shifts, because of the shifts, there is a isobar shifts in the seasonal pattern, that is during the monsoon season there is a shift in isobars. Low pressure, that is cyclone. So, the low pressure it will be the center and it increases outwards. Air rises, the cloud formation, the cumulonimbus clouds have been formed because of this process and it leads to rainfall. So, this is the main characteristics of low pressure, that is cyclone. The wind converge inward, the wind will be converging inward in the cyclone, and it rotates anti-clockwise in the northern hemisphere. So, in the northern hemisphere the cyclone will be rotating in anti-clockwise movement. The steep pressure gradients near the center creates strong wind. So, because of this steep pressure gradient, if the pressure gradient is steep, how it will leads to? It leads to strong wind. It is responsible for cyclone, depression, storms and monsoon lows. So, these are all the weather patterns which is led by the low pressure, that is cyclones. That is the high pressure anticyclone. The high pressure will be at the center, that is it will be represented as a letter H, and this high pressure will be decreasing outward. In the cyclone it will be increasing from the center. Here it is decreasing from the center, that is outward it is decreasing. The decreasing air causes the stable dry condition. So, in this region anticyclone high pressure region, the air will be stable and it will be in a dry condition. The wind diverge outwards. There the wind in the low pressure, the wind converge. Here in the high pressure, the wind diverge and the rotation will be in the clockwise, but in the low pressure it is the rotation will be anti-clockwise in the northern hemisphere. The anti-clockwise brings the clear skies and calm weather. So, because of this particular situation, there will be a calm stable weather will be there in this particular high pressure region. It will be having a widely spaced isobars which shows the gentle pressure gradients. Because of wideness, there is a gentle pressure. If it is going to be very closely packed, there will be a adverse climatic condition, that is pressure gradient. Pressure gradient. What is meant by pressure gradient? That is pressure gradient is the rate of pressure changes over a horizontal distance. That is the pressure is changing. If the distance is here, how far the gradient of pressure is there. So, that gradient, that change, pressure change is known as pressure gradient. It controls wind strength and atmospheric motion. The atmospheric circulation and then wind strength is controlled by this pressure gradient. This pressure gradient force initiates the wind flow, that is PGF controls the, that is initiate, it starts the wind flow. It is shown by spacing of isobars in the weather map. How it is shown? That is, if the isobars are closely packed like this, if the isobars are closely packed, there is a strong wind. If the isobars are widely spaced, that is here you can see the wideness here. So, there will be a light wind. So, in such a way you can read the weather map based on this pressure gradient. It is fundamental driver for the weather system. So, this gradient, the pressure gradient force is most important for the weather systems. What is meant by pressure gradient force? So, in the previous slide we have discussed about what is meant by pressure gradient. Here there should be some force. So, because of that force, that gradient have been changed. So, that force, what is that force? Pressure gradient force, PGF in short, arises from unequal air pressure between areas. There is not a similar pressure pattern, air pressure. So, because of this unevenness, this pressure gradient force arises. It acts from high to low pressure. Air will be traveling from high pressure region towards the low pressure region. So, this pressure gradient force is main force that starts the wind movement. So, if there is any wind movement, this pressure gradient force is most important. Its strength depends on steepness of the pressure gradient. How far the pressure is very steep, the strength will be more. The pressure gradient force works with the friction and Coriolis force to shape the wind speed and direction. So, it is not acting individually, it is acting along with the frictional, that is friction force as well as the Coriolis force. These three combine together to form the to determine the wind speed and direction. Isobar and pressure gradients, that is how the isobar determine the pressure gradients. Closely packed isobar indicate rapid pressure change over a short distance. Pressure gradient means the change of pressure in a specific distance. So, how we can analyze that is, if it is closely spaced, if it is going to be very close, the rapid pressure change occurs in the short distance, there will be a fluctuation. They create a strong pressure gradient force. They are created by strong pressure gradient force. It is also associated with high wind speed and turbulent weather. So, because of this excessive force, there is a high wind speed and there is a turbulence in that particular region. It is common in cyclone and depression. So, we all know that if it is going to be a cyclone or depression, it is not a normal state. There will be a disturbance in the air, that is a pressure. So, this is exerted because of this pressure gradient force. It is also important for storm warning and aviation and marine safety. So, the storm warning, aviation and marine safety have been determined by analyzing this pressure gradient, that is isobars. Widely spaced isobars. See here, there is a wide space have been there in this isobars. The widely spaced isobar shows the gentle pressure changes. So, pressure is gentle. If it is closely packed, the pressure is adverse. Here the pressure is very gentle over the area. The weak pressure gradient causes light and calm wind. There will be a gentle breeze in this situation. It indicates the stable atmospheric condition. The atmosphere will be very calm, stable in this widely spaced isobars. It is commonly linked with anticyclone and fair weather. So, if it is going to be a calm, stable situation, it is associated with anticyclone and fair weather. It is also important for weather planning and outdoor events. If we want to plan outdoor or if we want to travel, so what is much important? The stable situation is much important. So, because of this that is isobar reading, we can analyze that there is a calm situation, stable situation, and we can plan for outdoors and travel. Next one is trough. What is meant by trough? Trough is the elongated area. See here you can see this trough. So, trough is the elongated area of low pressure. So, here there is a low pressure. This bar bends inward. Be careful in listening it. That is, here the trough you have low pressure which is bending inward, and in the next upcoming slide you will be coming across ridge. So, it is opposite to this trough. So, you can see the changes in this too. Inward, associated with clouds, unstable weather and rainfall. So, if it is going to be a low pressure, there is a disturbances. And it is associated with the cloud formation, unstable weather condition and rainfall will be prevailing in this region. It is important in monsoon circulation affecting the rainfall patterns of that particular region. This zone of air conversion and rising motion cause active weather in this region. So, this is known as trough. Next one is ridge. So, ridge is elongated. Again here also it is elongated. Trough is also elongated. Ridge is also elongated. What is the difference? In trough you have the isobar which will be bending inward, but in the ridge the isobar will be bending outward. So, this is the major difference of these two major phenomena of air pressure. And then here you have high pressure. Here in the trough you have low pressure inside, but here you have a high pressure inside this ridge. It is associated with the descending air. There it is not descending. Because of descending air, there is a clear, dry, stable weather, and this ridge block or divert storm act as a barrier. So, this ridge act as a barrier for the wind movement, but the situation will be very clear, dry, and then stable weather will be prevailing in this region. So, unstable condition in trough and stable condition in ridge, where we can see such kind of weather pattern, that is in the subtropical highs you can witness this kind of weather pattern. Next one is col region. So, col region, col is a saddle shaped pressure area. So, the saddle shaped, it's somewhat like this. So, you can see like this, no, saddle, the area between two highs and two lows. So, two high pressure will be there, two low pressure will be there, and which is forming the col region. It have the weak pressure gradient. The pressure gradient will be very weak in this particular region and causing light and variable winds. So, because of that, the weather will be dull, humid and stagnant. So, the weather will be dull in this col region, and it is a transitional zone with minimal pressure change. So, it is a transitional zone between the high and low pressure region. So, this col is most important region which is analyzed in mid latitude weather systems. So, in middle latitude you can witness this col region. Isobar intervals, that is the standard isobar spacing is of 4 HPA, hectopascals, that is 4 hectopascals ensures the clarity on weather maps. So, if it is going to be a standard isobar spacing, so this will be the measurement, but the small pressure intervals are used for detailed regional weather charts. So, if it is going to be a detailed weather chart, the small pressure belt intervals are used, but if you are going to construct for the large scale global maps, how the intervals are chosen, the interval will be large interval. So, the preference of interval will be large in showing the global pattern, global map, and it will be a small interval in showing the regional weather map. So, based on the region, based on the area, the intervals differs, the isobar interval differs. The uniform spacing allows the accurate comparison of pressure patterns. If it is going to be uniform, there will be accurate pattern. The isobar interval reflect the level of details and sensitivity required for meteorologists. So, based on the isobar spacing, that is intervals, the meteorologist will be analyzing what kind of situation is prevailing in that particular region. So, this isobar interval is most important in reading the weather pattern. Wind and pressure gradients, that is wind flow from high pressure towards the low pressure due to pressure gradient force. Some force have to be exerted here, that is PGF will be exerted. So, because of PGF, the wind is blowing from high pressure towards the low pressure. The wind strength depends upon the steepness of pressure gradient. If the wind is steep, how the area will be? The area will have low pressure and it will not be a stable condition. The wind direction is influenced by earth rotation, that is Coriolis force. The direction is always determined by Coriolis force because it deflects the direction of wind. The local wind, that is sea and land breeze, because of uneven heating there is a contrastivity in the local winds. The global winds are controlled by pressure belts and circulation system, the air circulation system. So, globally the permanent wind, that is planetary wind are controlling the wind pattern, but locally the local winds are controlled by land and sea breeze due to the differential heating of earth's surface and water bodies. Geostrophic wind, that is geostrophic wind forms when pressure gradient force is and Coriolis force are balanced, that is PGF is equal to the Coriolis force. The wind blow parallel means it is blowing parallel to the isobars, it is not crossing the isobars here. it occurs high above the surface. Why? Where the friction is low. The friction is always above the earth's surface. It's somewhat nearer to the earth's surface. So, it controls the major upper air circulation pattern. So, this geostrophic wind controls the upper air movement. So, in the jet stream, this is most important factor. The wind speed rises with the steeper pressure gradient. The wind speed rises, steeper the pressure gradient, low pressure. If there is low pressure, the wind speed will be very high. So, this is the combination or connection between the steeper pressure gradient, wind speed and air pressure. Gradient wind, that is the gradient wind flow around curved isobars. So, it curved isobars is that the cyclones and anticyclones, where there is cyclone and anticyclone, you have such kind of activities. You can see the curved nature, spiral nature. So, in that situation, this gradient wind are flowing. They include the centripetal force from the curved airflow. So, the winds are strong near the low pressure center and weak near the high pressure center. If it is going to be low pressure, the wind will be very much stronger, and if it is going to be low pressure region, the wind will be somewhat weak in the gradient winds. The gradient winds give more realistic picture of the atmospheric flow than geostrophic wind. So, comparing with the geostrophic wind, this gradient wind have produced the realistic picture of the that is the atmospheric flow of winds and pressure. Surface wind, the next wind is the surface wind. The surface wind always which is associated with the friction. The friction slow the wind speed near the earth's surface. It is not crossing the isobar, it is travelling along the isobars. The angle of crossing depends on surface roughness. So, how the surface will be rough? So, it will be rough greater over the land than sea. So, why it is land than sea? The land will be having an undulating nature. There will be a elevated, that is erected buildings or mountains, highly elevated structures will be there in land compared to the sea which have the smooth surface. The friction leads to conversion of winds in low pressure areas. So, it causes the diversion of wind in high pressure areas, that is the conversion in the low pressure and divergence in the high pressure. So, where all these processes happening in the surface wind. So, the main factor which triggers the surface wind is friction. How to read the iso maps, that is it by identifying if it is going to be low pressure, L can be represented here. If it is going to be a high pressure, H can be represented in the center. So, by seeing the L and H, we can assume that it is a high pressure and low pressure. Observe the isobar spacing. So, we have to observe the spacing. If it is going to be a closely packed, the weather will be adverse. If it is going to be a widely spaced, the weather will be a stable condition. The high and low symbols have been represented by H and L. It helps to forecast the circulation pattern, that is air circulation pattern and weather events. So, in order to analyze the weather events and then air circulation, the reading of isobars in the map is most important. Cyclones on isobar map. So, how cyclones are identified? The cyclones is characterized by circular and closed isobars. So, you can see here the how the pattern is in the cyclones, and the atmospheric pressure decreases sharply in the center. So, in the center there will be a decreased atmospheric pressure. The tightly spaced isobars near the eye wall which produce a strong wind. So, each and every cyclone have the eye of the cyclone where there will be a tightly spaced isobars. The isobar pattern helps to track storm movement and potential land paths. So, how the storm movement is there and how the potential path it travels, all these have been identified with the help of these isobars in the map. They enable meteorologists to access cyclone intensity and severity. So, how the cyclone is whether it is an intensive cyclone or it may be somewhat less intensive can be read with the help of the spacing of the isobars. Anticyclone isobar map, that is anticyclone have a widely spaced concentric isobars which is have the weak pressure gradient, and it is characterized by the descending or subsiding air and stability. The wind diverge outside. So, in this high pressure, that is anticyclone, the wind is diverging from the center, and it forms the clear sky, low humidity, and few clouds will be formed because of this anticyclones. It indicates the prolonged dry and fair weather. So, if it is going to be anticyclone, there will be a fair weather in that particular region. Winter pressure pattern, that is in winter pressure which shows this strong land sea contrast. So, it is mainly due to differential cooling effect. The high pressure over continents will be prevailing and low pressure will be prevailing in oceans. So, because of that, the steep pressure gradients which cause the storm and cyclones in this region. The strong and meandering jet streams guides the storm tracks, the patterns which determine the winter severity. So, all these weather condition will determine the winter pressure pattern. Next one is summer pressure pattern, that is land heats rapidly in summer and forming the low pressure. So, in the continent there will be a low pressure and in the ocean there will be a high pressure. So, in the ocean which remains relatively cooler and have the high pressure area, the monsoon trough develops in the continental region, the monsoon troughs have been developed, the pressure belt shifts northward and there is a shift in the pressure belts. So, that slight shift towards the northward and southward, it is because of apparent movement of sun. The pressure gradients are weaker compared to the winter condition. In the winter condition, the pressure gradient will be very much stronger compared to the summer seasons. Applications of isobar analysis. The isobar analysis is used in mapping synoptic weather charts and in navigation, safe navigation, either it may be by ships or it may be by aircrafts. This isobar analysis is most important, and in agricultural weather forecasting, isobar plays a vital role, and climate research and climate pattern recognition, this isobar plays an important role. It is essential for anticipating extreme weather events. So, if there is a extreme weather events, now we can witness in the apps, number of apps are there. So, based on that app we can somewhat analyze the extreme weather patterns nowadays. So, in such a way the isobars plays a vital role, and understanding the isobar is also one of the most important factor. To summarize the entire lecture, the isobars are the line that joins the place of equal atmospheric pressure and is used on weather map to show the distribution of high and low pressure system. The pressure gradients refers to the rate at which the pressure changes over the given distance, and it also represents the spacing of isobars. The isobars are used in the synoptic weather chart. It plays a significant role in safe navigation, agricultural weather forecasting and climate research. Hope you understand the concept. In the upcoming lecture, we will be discussing on forces act on wind. Thank you.